Okay, I'm good to go. Okay, my name is Dale Skran, and I'm here from the. I guess I'd like to. Yeah, okay, like to. I have to move my slides forward here. Um, I'm here from the National Space Society. I'm the chair of the executive committee. Really glad to be back talking to you, even if it's remotely. And I would appreciate it if somebody could type something into the chat, letting me know that everything's okay. I guess the other thing I'd say is that if people in the room would like to tell the technical support staff, they could potentially ask me questions, and I'll try to fit them in when I can. So, yeah. I guess I'd like to hear a confirmation from the UACNJ that they're hearing me and everything's okay. But I'm just going to continue on. I previously spoken with this group, or with various groups, about my sort of long-running series comparing the Blue Origin rockets with their namesakes. So Blue Origin had the idea that they would create a series of rockets that that basically are named after the sort of the pioneering rockets of American spaceflight, the Mercury, they actually relate to the asteroids or to the astronauts. Alan Shepard, John Glenn, and Neil Armstrong. So one is called New Shepard, and that's a suborbital vehicle, which is not the subject of talk. There's one that is the subject of tonight's talk, the New Glenn, an orbital vehicle, and there's an intimation that there will eventually be something called the New Armstrong. I'm actually still looking for a text message from the Astronomy Club that they can see everything. I haven't seen anything since the "we are ready to go now" message, so I really appreciate seeing that. Okay, great. I've got the confirmation. Thank you. Appreciate that. So the slide you're looking at now shows on the left the Mercury Atlas with the Freedom or the Friendship 7 capsule on the top. We'll hear more about that later. And on the right, an artist's illustration of the New Glenn, and we're going to compare these two rockets. It's also maybe worth taking a little bit of a look at the two people most associated with the New Glenn. Obviously, John Glenn himself, first American to orbit the Earth, on the left, later U.S. Senator, later flew on the space shuttle. And on the right, in a slightly smaller picture, Jeff Bezos, founder of Blue Origin, founder of Amazon, richest man in the world, and extremely important person who's had a profound impact on everybody's lives. So, without further ado, talk a little bit about the mission of these two vehicles. The Mercury Atlas launch vehicle was, and I can see I have a mistake there. It says Redstone, but it should have said Mercury Atlas. But the capsule is correct. It was the Friendship 7. It was the first U.S. orbital flight. It was an ocean parachute capsule recovery. It demonstrated basically the ability of an astronaut to withstand zero G.
You're still stuck on the opening slide. You're not showing what you think you're showing.
Okay. Yeah, I've just been informed that for some reason
you're not sharing the correct screen. That's why.
Okay, so I've been told that you're not seeing you're just seeing the opening slide. I'm not sure why. I'm going to stop sharing and start again. This happens sometimes with Zoom, so I'm sorry about that. It just gets really slow, and it's not adequate here. So I'm going to do that and share again, and we're going to Why is this not working? Okay. I think I know what the problem is. Okay, I apologize for that. I think the problem here is I was sharing the wrong screen. Can you now see? Okay. Yeah. Okay. That was the problem. I apologize to everybody. I was sharing the wrong screen. That is the problem. Okay. All good now. So sorry about that. So back to the mission. I guess I'm going to go back through these slides a little bit because my guess is you didn't actually see them. So this is the slide showing the Mercury Atlas and the New Glenn. And then here we have John Glenn and Jeff Bezos, who I previously talked about. I'm really sorry that was not quite right. So back to the mission. The mission of the Mercury Atlas was pretty short, 3 orbits of the Earth, 4 hours, really about 5 hours. It occurred on February 20th, 1962. Now, this was a historic mission, and by comparison, there isn't anything quite as historic about the New Glenn. It's simply a new state-of-the-art launch vehicle for general launching of satellites to low Earth orbit and geosynchronous orbit. Originally, it was intended or competing in commercial crew, but Blue Origin lost out to Boeing and SpaceX. As you know, just recently, SpaceX brought back the first crew on a Dragon 2 from the ISS. So there really are no definite plans to fly crews on the New Glenn. It may happen. It's certainly something that they have a plan for doing it, but there's no definite plan, and that's the way I presented this talk. As far as the kinds of the duration, and obviously the missions are going to vary, but typically, since this is not a crewed mission, they're going to last. They're going to be years in length. There are going to be many, many, many orbits, and we can't expect to see a launch until probably late 2021. So going to the next slide now, and I'm going to say what the slide is, and if the slides stop advancing for some reason, please let me know. This is called the rocket, and we're going to get into some technical details about the rocket. I think I'm going to try to go left to right, comparing the Atlas to the New Glenn. So we're talking about the same thing. So the Atlas had a bunch of names. If you're like going to geek out, it was called Launch Vehicle 3D. It was called the Atlas D. But we're going to call it the Mercury Atlas because that's easier to say. It was derived from a ballistic missile. The New Glenn's a clean sheet of paper design. It is definitely not a ballistic missile. Obviously, the Mercury Atlas, manufactured by a company called Convair, no longer exists. And New Glenn, manufactured by Blue Origin, which is a new company that certainly didn't exist when the Mercury Atlas was around. The Mercury Atlas is a 1.5 stage rocket as compared to a New Glenn, which is a 2-stage rocket. And when I talk about the engines, I'm going to try to explain a little bit more about the Mercury Atlas. It's a little different than other rockets, and maybe a little tricky to understand how it works. The New Glenn is a little simpler. It's simply a 2-stage rocket, like the Falcon 9. The other thing you'll note is that the New Glenn's a lot taller, almost maybe 3 times as tall as the Mercury Atlas, and it's also much bigger in diameter, 7 meters versus 3 meters. And there's really no comparison in the payload capacity. The Atlas launched around 2 metric tons to Earth orbit, and the New Glenn 45 metric tons. So it's a very much larger rocket, and it's obviously a much more advanced rocket in a lot of ways. So there were 9 launches of the Mercury Atlas, and I'll go into that in a little bit more detail about some of the failures. Obviously, New Glenn hasn't flown yet. It's going to fly in theoretically 2021. Basically, the Atlas had what they call booster engines, and it also had a first stage with a single engine. The booster engines in the first stage shared turbo pumps, which is a kind of an unusual design, where the New Glenn simply has a first stage and a second stage with 2 different kinds of engines, while there actually is no second stage on the Mercury Atlas. So it's kind of interesting. If you're into rockets, it's an interesting thing to think about. The other big thing that's different is that the Mercury Atlas was powered by basically kerosene and liquid oxygen, while the New Glenn, the first stage, is methane and liquid oxygen, and for the second stage, hydrogen and liquid oxygen. So now I'm going to the science lecture slide on specific impulse. So one of the ways you compare rocket engines is something called specific impulse. And, this is a strange term, and I'm pretty confident the average person does not understand. And so I've decided I'm going to try to give an explanation of what it is, to just give you a little sense of one of the key technical points here. So it's a measure of how effectively a rocket uses fuel, and it's defined as a change in momentum per unit of fuel consumed. And oddly, it's measured in seconds. And don't ask me to go into that. This is just a brief introduction, because all the other terms cancel out when you do the math. Generally speaking, more is better. Hydrolox is higher than Methalox, is higher than RP1. But it's not just about specific impulse. There's other issues. The density of fuel is important. For example, hydrogen is less dense, so it makes the rocket really big. The damage the fuel does to the engine is important. One of the attractions of Methalox is that it doesn't coke up the engine. And of course, Hydrolox actually burns really, really hot and it's very reactive. Well, the thrust-to-weight ratio isn't really a function of the fuels, but it's a more function of design, but it's an important parameter. And then the absolute amount of thrust is important too. You'll often see NASA uses something called an ion engine, has a very high specific impulse, like thousands of seconds. But the thrust is actually very small in absolute numbers. You couldn't fly off the Earth at all with an ion engine. It's not enough absolute thrust to get off of Earth at all. But once you're in space, it's pretty useful. Anyway, this probably has more confused you than anything else. But if you carry something away from it, that's good. That's why it's called rocket science. It's complicated. So we're going to take a closer look at the first stage and the boosters. So just, I think one thing to note, the first line on the Mercury Atlas is that, it was built by Rocketdyne, which is sort of the dominant rocket engine provider up till now. And New Glenn BE4 is built by Blue Origin. So one thing we've seen recently is a kind of a passing of the guard in which really Blue Origin and SpaceX are the main rocket shops, and Rocketdyne has had a lot of difficulty competing with them and really isn't building innovative rockets that are cost effective. The New Glenn's really big. It has 7 engines. There are 2 booster engines on the Mercury Atlas, and you can see that the Mercury Atlas engines are just a lot smaller. They're like around 800 kilonewtons thrust versus 2,400 kilonewtons thrust. And then you gotta remember, you gotta multiply 2,400 kilonewtons by 7. So the total thrust of the New Glenn is really enormous. Another thing you'll notice is the specific impulse for the New Glenn is a lot higher. It's 380 seconds. And this is one of the reasons why the new rockets being built by SpaceX and Blue Origin use methane and liquid oxygen. It has a higher specific impulse than kerosene does, which is what was used in the Mercury Atlas. The burn time is not so important. We've talked about the fuel. They have I think the most important thing about the cycle is that the Mercury Atlas engines, you started them, they burned, and that was it. The New Glenn engines are restartable, which is really important if you want to recover the first stage. And then throttling is important as well. If you can throttle down, you have to be able to throttle the engine back to land. And you can't do that in the Mercury Atlas. It was never intended to land. So I'm going on to the next slide, which is titled, it's a picture of the BE4 LOX methane engine. And I think the thing to take away from this slide is that it's a really big engine. You can see a picture of a 6-foot human being there, and it's quite a large engine. Now we're going to talk about the first and second stages. Now here we're comparing another Rocketdyne engine, which is actually very similar to the booster engines. Because remember, they share turbo pumps, so they're basically the same engines, but they fire longer than the booster engines. Like I said, it's a kind of an unusual setup. I can't even think of an example of another rocket that worked that way. So I'm going to focus mostly on the second stage of the New Glenn, which uses something called the BE3, which you could say is blue or Bezos, depending on how you look at it. It's certainly a more powerful engine than the Rocketdyne engine used in the Mercury Atlas, but the specific impulse is a lot higher. 450 seconds versus the 215 for the Mercury Atlas. Now that is because it's hydrogen and oxygen. Hydrogen gives you it's more energetic, gives you a higher specific impulse. There are problems with hydrogen though, which is it makes for it's less dense, so the rocket has to be really big to hold all the hydrogen. And then again, I think the key point is it's a throttleable engine, and it can throttle down to 89 kilonewtons from 710 kilonewtons. That's a lot of throttling, and it's restartable. So it's a much more flexible engine. And then we're going to take a look at the next page. It's called BE3U engine. You should be seeing an image of the engine. And like I say, if for some reason you cannot see this, please put something in the chat so that I know about it. So the thing I want to focus on here is kind of a trivia point. Is how do you know this is a vacuum engine? Well, what is a vacuum engine anyway? Well, typically the second stage of a rocket is called a vacuum engine, and it turns out that you can greatly increase the specific impulse of the engine if you have an enormous nozzle stuck on the rocket. And that's what we see here. We see a really enormous nozzle, and I wish I had a picture of a person, but this is a really big nozzle. And it greatly increases the specific impulse. If you look at the Falcon 9, you'll see that the Merlin engine it's exactly the same engine on the first stage with a really big nozzle. So anytime you see a rocket engine with this gigantic nozzle, you know it's an upper stage engine. Anyway, so I'm glad to hear everybody can actually see stuff. Okay, so let me just keep going here. So now I'm going to talk a bit about the capsules, the return capsule. And this is going to be a very one-sided part of the talk. This is a picture of John Glenn getting into the Friendship 7. Because we don't really know anything about the return capsule for the New Glenn, there's not too much that I'm going to kind of go lightly over this. I think the Mercury capsule is really well known. The things I want to point out about the Mercury capsule is it had a pure oxygen atmosphere. We hadn't quite figured out that was a really bad idea until the Apollo 1 fire. It was not large, it had a curve 1. I've seen, if you've ever gone to the National Air and Space Museum, I highly recommend that. Go take a look at a Mercury capsule. It said you did not fly the Mercury, you wore the Mercury, and it is extraordinarily cramped. And the other thing is, keep in mind, is all those Mercury 7 astronauts were very short men. They were not tall. So, in any case, the other thing that was kind of interesting is that the Mercury had what's called a pull abort system, which, as we'll talk about a little later, actually was proven to work. And solid fuel, it's not how abort systems are done these days, and that's sort of a whole other talk to itself. We had a shift from, these are called polar abort systems. The New Shepard uses a push abort system. The Dragon 2 uses a push abort system. The Starliner uses a push abort system. So, it turns out there's some advantages to that. That basically it increases the envelope in which you can escape. But I'll come back to this. This is, like I said, this is a weak part of the talk because the plans of New Glenn for human crews it's pretty much on the back burner right now. So just there's a historical note. I'm looking at a slide called the launch site. This is just to give you a kind of a brief tour through history. I don't know if you can see my cursor, but you see the big arrow. This is where the Mercury Atlas was launched. Launch Complex 14, New Glenn is being launched from 36, which is like right in here, and 36 is a very historically important launch site. It's where the Pioneer, the Surveyor, and the Mariner probes were launched in the 60s and 70s. But now it's been leased by Blue Origin and also a company called Moon Express to launch their vehicles. Anyway, that's one thing I just want to note here. By the way, the picture on the left is Launch Complex 14 in its glory days when it was launching the Mercury Atlas rockets. Cape Canaveral has a really large number of launch complexes. I don't think this is well understood sometimes, but this is not a small number here. Going on to the next slide. So we're talking about reuse strategy. The old one, reuse strategy, was very specific. The rocket was dumped in the ocean, and the fish used it, if anybody used it. I'm not trying to make fun of it, but it is fact. That is what was done with it. With the New Glenn, we're sort of in the new era, the post-SpaceX era, and the plan is to reuse the first stage by landing it on an ocean-going ship. Now, this is different from SpaceX in a number of ways. So first off, there's no intention at all to return to the launch site. So I guess they have a more uniform process. There are more landing legs than there are in the Falcon 9. There are 6. And the control structures are somewhat different. There are these 4 forward fins and things called strakes, which are the unusual shape protuberances here on the bottom. And so, but it is based on the proven New Shepard landing technology, so I don't think there's a lot of doubt that it will work. Moving on to the next slide. But for the second stage of the New Glenn, same reuse strategy as Mercury Atlas, dump in ocean, used by fish. So we're going to take a quick walk through memory lane and look at what happened with the Mercury Atlas. And the point I'd like to make about this is that people tend to forget that it's difficult to do this stuff. And every time they see a rocket blow up, they say, "Ha! What fools they are! They blew up that rocket." Well, let's take a look at what happened with the early days of the Mercury Atlas. So on the first flight in July 29, 1960, they had a structural failure 58 seconds into flight. Structural failure is a euphemism for the rocket fell apart because it was just couldn't take it. It turns out the early Mercury Atlas rockets had kind of thin steel skins, and they didn't work very well. So they reinforced the skin with like a whole bunch of extra belts of asbestos and steel, and they actually got Mercury Atlas 2, and which was in early '61. They recovered the empty capsule, and it was after a short suborbital flight. So they thought, okay, they're doing great. And then they moved on to Mercury Atlas 3, and they sent a destruct signal after 43 seconds. The reason for that is that the guidance went completely catawampus. It was supposed to sort of flatten out and go out over the Atlantic Ocean so they could recover the capsule, but that isn't what it did. It got locked into sort of a death, just like go into deep space as fast as you can, and that's not what it's supposed to do. It's actually really bad because it would have blown up eventually and scattered debris all over Florida, which they did not want. And the thing that's remarkable about this is that the escape power fired after the explosion, and they recovered the capsule, which is a real testimony to the excellence of the engineering. It is likely that had there been an astronaut there, they would have survived. So in Mercury Atlas 4, they finally got an empty capsule to make a single orbit of the Earth. So it's the fourth time is the charm, apparently. Mercury Atlas, which is I think mislabeled MR, it should be MA. It put Enos the chimp, who's less well known than Ham the chimp, but people should know about Enos the chimp. I guess the first American chimp to make 2 orbits around the Earth. And then finally we had Mercury Atlas 6, which carried John Glenn into 3 orbits around the Earth. I decided not to go over 7, 8, and 9, but there were 3 more successful crew flights, which expanded the envelope of operations of the Mercury capsule, and all were successful. So this is a remarkable record. It's a real little piece of history. But the thing that I take away from this is it was never easy. And, NASA had the best people, the most money, and they still had a lot of problems. So it's just something to keep in mind. So let's go on to the next slide. And the next slide is the table of planned New Glenn flights. Well, now this is, as I said, it's a bit disappointing because it's not that historic. It's intended to be a workhorse rocket to launch geosynchronous comsats, and now the new cool shiny new thing, LEO broadband constellations. And the way this is listed, this is actually a really good manifest for a rocket that hasn't flown yet, and it expresses a lot of industry confidence that he's the richest man in the world. If he wants to make it work, he can make it work. It's a good manifest, though. It suggests that there's going to be enough business to maintain the New Glenn competing with SpaceX. And I guess the other thing is there's a lot of people who hold back and won't make a commitment until after the rocket's flown. So I would anticipate that after the first successful flight of New Glenn, you'll see another 10 or 15 people will come out of the woodwork and sign contracts. I do want to emphasize that this contract with OneWeb, this is a great deal, 5 launches at 80 satellites each. But OneWeb went into like Chapter 11 and they got restructured. Now they are coming out of it. They have new investors, including, I guess, the British government. But whether they maintain the old contracts, I don't really know. So let's go on to the next one. So Blue Origin has done a lot of work in terms of building the infrastructure for New Glenn. They have a shiny new rocket factory, and this picture doesn't really give the full sense of the building. It's a very, very large building in Florida in Exploration Park. And they've also constructed a shiny new mission control center for New Glenn, and I think this this certainly conveys the impression that it is a shiny new mission control center that somebody spent a lot of money on. And they have been doing a lot of work on the engine very recently, July 1st, and now we're talking about, just a little more than a month ago, they delivered what's called a Pathfinder engine to the United Launch Alliance. Now, one of the strange things about this business is that in addition to using the Vulcan or the BE-4 in the New Glenn, they've also sold it to the United Launch Alliance as the engine for their next generation vehicle, the Vulcan. So that's interesting. So and we can be sure the Vulcan and New Glenn will compete. In fact, they have been competing in a competition between the SpaceX Falcon 9 and Falcon 10 Heavy versus United Launch Alliance Vulcan versus the New Glenn versus the Northrop Grumman Omega, and for national security launches for the next 5 years. And as it turns out, SpaceX and United Launch Alliance won that contest. So, but sort of Blue Origin won too, because the Vulcan will be using the BE-4 engine, and that really puts the Blue Origin in a good position. So this picture we see here is the Pathfinder engine, and the reason this is like a complete working engine, and it's designed to be taken and attached to the rest of the rocket so that you can verify that you do what's called a fit test. And you can just kind of look at that and see all these like wires and cables and tubes and stuff, and just imagine somebody came and gave you a wrench and said, okay, now take that and attach it to the rest of the rocket. that would give me pause. So clearly it's a lot of work, and it's very likely that some of these are like in the wrong place, or maybe they have the wrong kind of thread diameter or something. So they really need to test that. On the other hand, this is not the same thing as a test engine. So I think once they deliver the actual production engines, you certainly within a year you can expect the Vulcan to fly. We'll come back to that in a little bit. Okay, so the next slide. The next slide is what now, New Glenn? So we're getting around close to the end of the talk here. So we're going to look forward and say, well, what does this all mean? Obviously, New Glenn's a fantastic rocket. It's incomparably better in every way than the Atlas, the Mercury Atlas. It just is, and it's been a long time. So it's good to take a breath and look back and say, wow, maybe we did learn something in all those years. The claim first launches in late 2021. COVID-19, as you probably heard, has certainly caused some delays. And I really informed observers, and I'm not talking about myself here, but people like Eric Berger of Ars Technica, they expect it to slide into 2022. There's a general rule in rocketry that when people start saying the first launch is in October, November, December, that really means at least March of the next year. Because once it gets to late in the year, it almost always slides into the next year. But that's okay. I think we can be very confident it will happen in that time period. Now they've had a lot. Blue Origin's had a lot of impressive infrastructure. I showed you the factory and the control center, and they have done work on the rocket, on the engine, on the BE-4 engine. And by the way, the BE-3 second stage actually is in very good shape. So I think this may really understate the progress. Because the BE-3 is basically a New Shepard with a big nozzle on it, and the New Shepard has been very extensively tested. So it's in pretty good shape, and I think it may well fly in 2021. And the Vulcan, I think, will certainly fly in 2021. And I think one of the general rules in looking at the realism ratio of rockets is if the engines are well tested, then probably the program will succeed. And if the engines are not good, nothing will save the program. And this is a situation where, and you do have to give it to Blue, that between the testing in the New Shepard with the BE-3 engine and getting the BE-4 engine into the Vulcan, those engines are going to be very solid when the new Glenn flies. Now, there's still going to be problems. I would expect some crashes, but it's gonna work eventually. But this is not the big problem of New Glenn. It was designed to compete with the Falcon Heavy, and it will be very competitive with the Falcon Heavy. It will launch 13 metric tons to geosynchronous transfer orbit versus the Falcon Heavy, 8 metric tons in reusable mode, which is the mode that really counts because it's the most cost-effective. I mean, the Falcon Heavy can beat that in expendable mode, but I'm sure the New Glenn can beat it in expendable mode as well. So I think let's give Blue credit. They have built a Falcon Heavy killer, and it may well be that they could be very, very effective competing with the Falcon Heavy. And I just also, everybody always asks in my talks, well, how does it compare to the Saturn V? This slide's a little dim probably because it's a Blue Origin slide, and they want to make their the New Glenn really bold and sharp. But you can see over here is the Falcon Heavy and the Falcon 9 and the Vulcan, very similar size, and the Atlas V, which, by the way, the Atlas V is a very significant evolution from the Mercury Atlas. And that would be an entirely different talk to, like, maybe the evolution of the Atlas, which I'm not, it would be interesting, I guess. And, here, the Ariane 5 and the Soyuz, and then the Antares, which brings cargo to the space station. And, of course, the venerable Saturn V. And you can see here the Saturn V is still bigger than any of them. But the point here is the New Glenn is a really large rocket. It's a 7-meter rocket. The Falcons are 5-meter rockets. And the New Glenn is not quite at the level of Saturn V, but it's actually kind of close. And it's a huge improvement over the Saturn V in the sense it's going to be, the whole first stage is completely reusable, and it's going to be it's much more cost-effective than the Saturn V. And compared to the Falcon Heavy, the Falcon Heavy has these side boosters, which make it operationally a lot more complicated than the New Glenn. So if you think about the Falcon Heavy, the 2 side boosters have to fly back to the launch site, and then the middle booster has to land on a boat. So the whole thing's really complicated, and there's more room for error. And you can see that the SpaceX has yet to recover the center core. They've had 3 Falcon Heavy launches, and they've always recovered the side boosters, but they've never completely succeeded in recovering the center core. They landed one, and then it actually fell over in a storm. So that was sort of bad luck. But the point is, this New Glenn is a good competitor to the Falcon Heavy. But, and this is my last slide, the New Glenn is actually not going to compete with the Falcon Heavy. It's going to compete with a new SpaceX vehicle, the Starship Super Heavy. And what we see here is an actual picture. I love this picture because it looks like a CGI or a painting or something, maybe a Turner painting. Turner was a British gentleman who loved to do beautiful sunsets and stuff. This is an actual picture from a drone of a test that took place, 10 days ago. So very recently. And it was a 150-meter test rate of what they call serial number 5 prototype of the Starship. And this is a kind of a freaky thing because you don't see any legs here. There are legs that pop out from the bottom, like these 6 spindly, like spider legs. It's kind of weird when you actually see the video. And this thing at the top, this is a mass simulator. Normally there would be like a fairing up top that would actually contain the crew or the cargo or whatever. But they were doing early tests, so they decided not to attach that, and instead they have basically a giant cube of steel that simulates the extra weight up there. This is really pretty remarkable. This is a liquid methane engine. They call it the Raptor. By the way, methane oxygen engines, they burn blue, and they have these little diamonds. They're called mock diamonds, so they're very unique. You can always tell when it's a liquid methane engine. And they're building the second stage first which is actually kind of what the Blue Origin did. They got the New Shepard, which really is the second stage New Glenn, and they got that working before they really started working on the first stage. I think part of this is there's a perception that second stages are harder, and that you need to get them good before you do the first stage. Anyway, but this is going to be a fully reusable 9-meter diameter launch vehicle, which would be significantly larger than the New Glenn, and because it will be fully reusable, probably significantly cheaper to operate. But it will use liquid methane, and right now this version only has one engine. Eventually, I believe there are going to be 7 engines in the second stage, and they will be vacuum engines with the giant valves. So they got a lot of work to do here. That's a whole other talk going into maybe comparing New Glenn to the Starship. But with that, I think I'll draw this to a close. I hope that you've enjoyed the talk, and I would be happy to entertain questions from the chat if people can tolerate this sort of very limited communications mean. But I won't be insulted if you just want to send me on my way. So thank you very much. Okay. Okay, so it says it seems like there's no questions. So thanks for having me. And if you could get in touch with me later, Diane, and let me know, or Kim, and let me know, where you're going to put the video up. That would be great. So I guess I'm logging off. Thank you very much.